Hello everyone, my name is Sheikh Arif Rehan. I am going to present a project we have designed for the course vlsi 2. The title of the project is to design a 10 to 4 line priority encoder. The objective of this project is to design a medium scale integration chip named 10 to 4 line priority encoder from concept to layout, including the placement of input output bits. We have also checked DRC error, LVS, and we have checked tape out for this design to develop GDS file. Basically, a priority encoder encodes information from 2 to the power n inputs to n bit codes. In a priority encoder, each input has a priority associated with it, and in our project we have assigned the priority to the inputs in ascending order. From the truth table we can see this. For input A0 pin, we have the lowest priority, and the output pins Y3, Y2, Y1 and Y0 indicates 0 0 0 0, which is the active input of A0. And similarly for A1, the output pins Y3, Y2, Y1 and Y0 indicates the 0 0 0 1, which is the active input of A1. And in our truth table, as we have assigned the priority as in ascending order, so the priority of A9 pin, input pin A9 has the highest priority. And when all the input pins from A0 to A9 are 0, then the output will be active high. We have implement this truth table in boolean equation. So the output pin Y3 has the boolean expression we have shown here, and similarly for Y2 this is the expression for Y2 pin, and this is for Y1, and so on. We have implement this boolean expression in our logic circuit, which is showing here. The input pins are in the left side of the circuit, and in the right side there are 4 major blocks which are for output pin Y3, Y2, Y1 and Y0. In the lower left corner we have here is the logic circuit for output AA. These parts are designed to implement the first row of the truth table, where if every inputs are 0, then the output pin will be 1. Basically it is a NOR gate, 10 input NOR gate. So we have designed this 10 input NOR gate by using 3 input OR gate and 1 NOT gate. And we have designed this total circuit using cadence tools, and we have designed the schematic diagram and layout of the circuit. For each block there are NOT gate, OR gate, 2 input OR gate, 3 input OR gate, 2 input, 3 input or 4 and 5 input AND gate. We have designed by CMOS in gate level transistor. This is the schematic diagram of our complete circuit, and here we can see that this part is input for input pin. Here we have used buffer circuit to get the smooth and precise active high or active low circuit. This part is for Y3, output Y3, this part is for output Y2, and this part is for output Y1, and this part is for output Y0, and this block is for part A, which I have already discussed. Here is the symbol and wave shape of the NOT gate we have used in the circuit. This is the symbol and this is the wave shape. This is the schematic of NOT gate, and this is the layout of the NOT gate circuit. 2 input OR gate is showing here, and this is the wave shape of 2 input OR gate, schematic diagram, and this is the layout of the OR gate circuit. 3 input OR gate, wave shape of the 3 input OR gate, schematic of OR gate. Here one thing I want to tell that for OR gate circuit, the PMOS are connected in series and NMOS are connected in parallel, which are showing here. the layout of 3 input OR gate. This is the VDD, this is the JND, and this is the body of NMOS, which is connected to ground, and this is the body of PMOS, which is connected to VDD. And this is the 2 input AND gate, wave shape of 2 input AND gate, schematic and layout, and so on. This is for 3 input AND gate, wave shape, schematic and layout of 3 input AND gate. 4 input AND gate, this is the symbol, this is the wave shape. From the wave shape, 4 input AND gate, we can see that if every input are active high, then the output will be active high, which is showing here. And schematic of 4 input AND gate, and this is the layout of 4 input AND gate. This is the 5 input AND gate, this is the 5 input AND gate, wave shape of 5 input AND gate, schematic diagram and layout. This is the part of schematic of the part AA. These are the 3 input OR gate, and this is NOT gate. We have used the block, the layout of the circuit. These are the layout of 3 input OR gate, and this is NOT gate, layout of NOT gate. This is the complete circuit diagram for schematic for circuit. Here is the wave shape of the complete circuit. We know that when if every input pins are low, then the output will be high, which is showing here. When every input is low, then the output pin Y3, Y2, Y1 and Y0 are showing active high. And when the input pin A0 is high, then we can see that the output pin is 0 0 0 0, which is indicating the active input pin A0. And when the input pin A1 is high, then either whether the A0 is high or low, the output pin Y3, Y2, Y1 and Y0 will be showing 0 0 0 and 1, which is the active input pin A1. Similarly for A2, when the A2 this is the A2 wave shape, and when the A2 is high, then the output will be 0 0 1 0, which is the logic which is the active input of A2. And similarly for A3, when A3 is high, then the output pin will be 0 0 1 1. So Y3, Y2 and Y1 and Y0 is showing 0 0 1 1. Similarly for A4, when the A4 is high, then the output will be 0 0 1 0 0. So here we can see that the output is 0 1 0 0. And here in this wave shape, we can see that when our input pin A5 is high, then whether this input pin A0, A1, A2, A3 or A4 are high or low, the output pin will always showing 0 0 1 0 1. So Y3, Y2, Y1 and Y0 are showing 0 1 0 1. Similarly for A6, the output pin is 0 1 1 0, and A7 0 1 1 1. For A8, we can see that for A8, when A8 is high, the output is showing 1 0 0 0. When A9 is high, then output is showing 1 0 0 1. And this is the result, and this is the result of our circuit diagram. Layout of our circuit diagram is showing here. In this diagram, we have used input output pads for the pin, input pin, output pin, VDD and JD. Actually we have placed this input output pin in a random manner. We should place this input output pin in either bidirectional or quadridirectional to design the circuit, design the medium scale chip. As a result, our total area has been increased. So the number of MOS we have used are showing in this table. the area of the layout design. As we have used as area, our total area has been increased because we couldn't compact our design. So the complete layout for the total area for the complete layout is 13,329.766 micrometer square. Delay are we have calculated delay for every block and every gate we have used in the circuit. The delay for the complete schematic is 9.88 nanosecond.